the tokenization concept, that is the matching. So we'll be starting the match. Basically there are two things, match and merge. So first let's concentrate just on match. Then after a few days we'll talk about merge. Okay, so concentrating on the the match, there are actually two things in match. One is pre-match, one is a post-match. Before matching, after matching. Not post-match, actual matching. So first is you prepare for the match, then we have the actual match. Okay, and the pre-match is also called as tokenization. Actual match is nothing but just match. Pre-match is tokenization. Okay, that's the key concept. Now today we'll focus just on the pre-match, the tokenization. That's our focus, tokenization, to understand that. Okay, and what exactly is tokenization and all that we will see. But before that, just let's talk about, just say directly you want to go with matching. Then let's say I've got records like this, CKR 101, so I've got three records like this, 101, 102, 103, John K Smith, let's say. Okay, so this is the data that I have. Now let's imagine that I am trying to, my party table is basically blank, let's say, is blank in the sense, this is the first time I'm doing the load. Okay, first time. Now what will happen here, since this is blank, so basically what happens when I load the data, I will load these three records into my party table. All right, so three records will be loaded, consolidation indicator will be 4, right? Now we'll talk about the match process. So just imagine how matching can happen, how matching will happen. Matching, maybe it will happen between these two records, between these two records, between these two records, sorry, see, between this and this and this, okay, and between these two, isn't it? I mean, if I don't have any idea on matching, what I'll do is I will just try to match this with this with this, then probably this two I'll try to match. That is a layman's way of performing the match. Okay, so clear, you understood, right? I mean, how I will match, I'll match based on attributes, saying that okay, if names are identical, if addresses are identical, if phone numbers, bank account numbers, that's identical, then declare that declare this as a match. Okay, so that's something that I can do. Understood? Very simple scenario. Just I will, what I'll do is I'll do some calculations. So this one, how, first of all, what is a match pair? What is a match pair? Match pair, what is a pair? Pair means two. That's the English meaning, right? Pair, two. So match pair means when you want to perform the matching, then which two records you want to match, and that's a match pair. So for example here, I'd like to match this record with this. So that's one pair. Then I've got like this with this. That's like the second pair. Then I've got like this. Then I've got like this too. That's probably the third match pair. Third one is not necessary, but let's just put it. Okay. So how many match pairs? You understood what's a match pair. Match pair basically means I've got three match pairs here, and 101 and 102. That is one match pair. 101 and 103 and 101 and 102 and 103. These three match pairs I have. Okay. Now, so it was like I've got only three records, so I did counting. It was easy. Let's say complicated. I've got six records. So how many match pairs? Clear? I've got six records. So how many match pairs can I expect? Difficult to answer, right? So now we will apply mathematics. So let's apply some mathematics. So from mathematics point of view, it is called as 3 combination 2. Okay, 3 combination 2. That is the thing. Okay, 3 combination 2 is equal to 3 factorial. It's like high school mathematics divided by 2 factorial into 1 factorial is equal to somewhere around 3. Okay, simple logic. So that's why how many match pairs I've got, like 3. So internal 4 with 4. 4 with 4 means consolidation indicator 4 with consolidation indicator 4 means new records, and that number is equal to 3. Clear? Simple logic. Okay, so this is a very basic scenario. Now let's complicate this a bit. If I complicate this, then 1 second. Okay, so
Can you
let's
re-explain that 4 into 4 equal to 3?
4 means consolidation indicator 4, consolidation indicator 4. All of these have consolidation indicator 4. The total number of match pair is equal to 3. Now let's imagine that the table is not blank. So let's say that the table is not blank already. Let's imagine 1 million, or let's say 10 million records are there already. Clear? So my base object has got, earlier it was blank, and we have total 3 match pairs. Okay. Now let's say that my base object is not blank. My base object already had 10 million records, and match and merge is done for this completed, done for this 10 million records, match and merge. Okay, so all of these 10 million records have consolidation indicator as 1 because they've already gone through the match merge process. Clear? So that is the situation. Now I have loaded 3 more records. These 3 records I am loading into the base object. So how many records will I have in the base object? 10 million plus 3. Clear? I will have 10 million plus 3 records. What is the difference? 10 million records will have consolidation indicator 1. These 3 records have consolidation indicator 4. Clear? Very simple. That's a simple load scenario. Okay, now let's talk about the matching. So see, in the matching now, I've got like, these are the different cases: 4 with 4, 4 with 1, with 1, 1 with 4. 1, 4, what are all this? They are nothing but consolidation indicators. Okay, 4 with 4 means consolidation indicator 4, records with consolidation indicator 4, uh, matching with records consolidation indicator 4. 4 with 1 means records with consolidation indicator 4 will match with consolidation indicator 1. That is the meaning. Okay, so this one, 4 with 4 means basically again these three records will match with each other. So what is the count in mathematics? 3C2. Is that the count? Yes, that's the count. Okay. Now 4 with 1 means, what is 4 with 1? So this is 1, 10 million records. 4 with 1, something like this. So it means this record is 4, this records they are like 1. Okay, so this record will try to create a match pair with all these records. Then the second record will try to create a match pair with all this. Then the third with all this. So how much the count will be approximately? Um, Approximately the count will be like 1 into 10 million plus 10 million plus 10 million. Clear? Clear, right? So that is approximately is equal to m cross n. I will just put it as like m cross n is equal to, in our case, m is 3, that is this number is 3, cross n is 10 million, that's equal to 30 million. Clear? Any doubts you can ask. Okay, so 30 million what? Match pairs. So we are talking about match pairs, all right? And the third one, this one, 1 with 4, how much is that count? 1 with 4. You understood what is 1 with 4? 1 with 4 means 1 tries to match with 4. 1 tries to match with 4. Is it possible? No, it's not possible. This is 0 because it's not possible. You understand, right? Because 1 will never match with 4. 4 will match with 1. That's okay. But 1 will never match with 4. Why? Because 1 is already in the VIP list. 1 means master data. So why a master data will try to participate in matching? I mean, 1 will participate but not actively. So it will be 4 cross 1, but 1 cross 4 is not possible. Okay, so this number is will always be 0. Just to explain you, I have put it. Normally this is what happens. Matching happens between these records. It can also happen between 4 to 2 as well, but that will be a very small list. So total how much is that in mathematics? 3 plus 30 million. I would just say, let's say like 30 million. So the count is like total number of match pairs is equal to 30 million approx, 30 plus 3. Alright, so 30 million match pairs. Just to match 3 records, I'm talking about 30 million match pairs. And 30 million match pairs, what do you think? How much time will it take? to execute 30 million match pairs. Probably 3-4 hours, 10 hours, 2 days, 3 days, something like that. So to match 3 records, I will need 3 days. Is it possible? I mean, is it a feasible solution? Of course not, right? So this number is troublesome. I can't allow this number. Okay, so this is a Cartesian method of creating match pairs. It's a Cartesian method of creating match pairs. I'm not giving any condition, anything. I'm just blindly creating the match pair. And the problem is this is close to infinite total number. So this will take forever. So my objective is I want to break it down. This number, I want to break it down to something very less, very low. Okay, something like less than 100 for 3 records. Then I can go with the matching. Alright, so how can I do that? Let's see how can I do this. What I will do is same thing, same strategy. I will just slightly put an additional condition. Over this logic, I have just put an additional condition. And that additional condition is create match pairs, MP match pairs, match if two people, two guys have same address. If two people, so if two people have same address, then only create the match pair. Create the match pair only if. So this is only if two people have same address. So what is this is the additional condition I put it. Okay. And with that condition, let's count the total number of match pair. So 4 cross 4 is equal to, let's check it, 4 cross 4. So these 3 records are 4, 4, 4, these 3 records. So the address should be same. Is the address same? Yes, it is same. So this will match with this, then this, then this. So probably here the count won't change. So here it will be like same 3. Okay, same 3. Now 4 with 1. What will be the count? 4 with 1. Let's imagine, let's say I've got this 10 million records here in this box. Okay, 10 million. Now what do you think? Just use your brain. What do you think? In this 10 million, how many people will be there who have given the same address as this? Same address as this. What do you think? How many people will be there? 100, 1 million, 10 million? At max there will be 3-4 people, right? Because in developed countries addresses are always accurate. So no one will give like, I mean it's not possible that 1000 people have same address until unless it's an office address. Okay, so at max this guy uh, will see 5 people. So 5 match pair for this, approximately 5 for this, 5 for this, right? That's the max number. So that is equal to how much? Somewhere around 15. Total number is 18. So this 30 million,
Why, Sunil, why 15?
15 is, I'm just approximately putting that every guy has approximately 5, uh, there are approximately 5 people which have the same address in my 10 million customer list. Can be more like 10 also, but not more than that. because it's exact address. Okay, so it's just 5 is just an approximate guess. So let's say somewhere between 15 to 30, 5 to 10. Okay, so this would be somewhere less than 30. Okay, that's the thing. Total number is less than 30. Less than 30 is okay because it will execute in few seconds. Okay, so you can see that I have brought down this number from 30 million to less than 30, just using this additional condition. Okay, using this additional condition I've done it. Clear? Simple. But I still have a problem. The problem is, let's say this is A, B, something like this, A, B. Then how many match pairs will this be? 4 cross 4. How many match pairs? 0. And how many match pairs for this? Approximately 0 to 10, somewhere around. So let's say just 0. So this becomes like 0. Clear? So this is working fine, but the only problem is if the addresses vary slightly, then this logic will not work because it will check the same, means they must be exactly same. Okay, so this is a bit of headache for me. How to fix that? To fix it, I will create a third strategy. Copy paste this one. I'll create a third strategy. Instead of using the same, I will say they have something like identical address or similar, you can say, or something like fuzzy or probabilistic. Okay, so all these words are same. They means fuzzy style of matching. So it's just like checking the percentage. So it's just like checking the percentage. For example, if I go here, then Sunil K. So I'll just check what is the similarity. Okay, it's greater than 80%. So it's a result is match. That's called as fuzzy. Okay, or similar or identical or probabilistic. So what I've done is instead of the same, I will just say like this. Okay, now let's see how many match pairs will it form. 4 cross 4. So what do you think? Do you think this is identical to this and this is identical to this and this is identical to this? So it is identical, right? So this one will be approximately like 3 and 4 cross 1, that would be approximately like somewhere around 20-30, right? Because out of the 10 million there will be approximately like for every guy, for this first guy, there will be approximately like 10 people with say identical address as this. Let's say just assume somewhere around 10 practically. So this number turns out to total number approximately it's equal to 30, let's say. So we have seen three methods, 1, 2, 3. Okay, out of the three methods, the first method is just for your understanding. The first method will never be used by any matching tool. It's just for your understanding how matching works. Okay, talking about the second method, yeah, second and third method are used. Third method is most widely used. Clear? Third method, it's most widely used method. Third one, sorry, this is three, third one. Second one is something that normally we don't use it much, but in Informatica you can configure this rule and this rule. These two things you can configure. In fact, Cartesian also you can configure, but it would be really foolish to do that. Clear? So, but still I have one problem. The third logic is fine, but still I have a problem. The problem is this. See, if I say that, if I'll ask someone, do you think this is identical to this? I'll ask someone that, do you think this is identical to this? He might say that, yeah, it's identical because they look same and there's a slight variation. I'll ask one more guy, a different person. He will say like, no, why do you think they are same? They're different because, so this is like house number extension. He's living at a different extension, and this guy is like probably in the ground floor and he's in the first floor, he's in the second floor, something like that, and they are different. They are not same, they're different. Okay, so someone is saying that this two is identical, someone is saying that it's not identical. So what will a computer think? How will a computer find if it's identical, not identical? Understood, right? How will a computer decide if it's identical or not identical? That thing is called as tokenization. That's what is called as tokenization. Clear? So let's try to understand. See, I have asked a question, right? On what basis Informatica will identify that this, and this are like identical? You understand? That's the question. And Informatica will answer the question using tokenization process. That's what tokenization process does. Exactly, this is what it does. Identical records, finding if two records are identical or not. Okay, but the style is slightly different. Okay, this is the style. Okay, see, token. First of all, what is a token? What is a token? Token in plain English, it's a 8-char alpha numeric value. All right, 8-char alphanumeric value would look something like this, isn't it? It would be something like this, right? 8-char alphanumeric. So that's called as a token. All right. Now try to understand. Tokenization is a process where Informatica generates tokens, and the logic is like this. Informatica will take this address. You understand? Informatica will take this address and it will generate almost like 7 tokens. Clear? So 7 token for this guy, 7 token for this, 7 token for this. For every new record, it will generate 7 tokens. Clear? 7 tokens. Now, if see something like this, it will be, so this is 1 token. They will vary slightly. Okay, so somewhere around this. Dot dot dot. Okay, then here you understood. For every record, it will generate 7 tokens. Now question number 1, on what basis it does it? That is internal. You don't need to worry what basis. So just understand that why you might be thinking, okay, why Informatica is generating like AUTP, something like that. I don't like this AUTP. Can I change it? No, you can't change it. That is internal to Informatica. So it just generates this number. Okay. Now the logic goes like this, that if there is any token, single token, if is common between two records, like for example, you can see this token, the second token here, and the first token here are the same. So if the tokens, if there is a single common token, then a match pair is formed. Clear? So for every record, it will generate approximately like 7 tokens. And if there is a single token that is common, at least one token, is it possible that all 7 tokens are same? Possible. That's possible. But doesn't matters. If one token is same, that is enough. If only one token is same, that is enough. You don't have to check if all are same. It's not necessary. Okay. So if the tokens are like same, then match pair is formed between these
Why
two
it will
records.
form 7 tokens?
Yeah, so I'll come to that. I'm just coming to that. First, this thing should be clear, right? This process should be clear that if token is same, then it will create the match pair. Now coming to the number 7, I've said like 7 tokens. What's so special about 7? It's nothing like 7 token as such. It's dynamic. Okay. So for example, see, if there are two people, a fat person and a like very slim person. So the fat person and slim person, if they go to a restaurant, so fat person will definitely eat more and slim person will definitely eat like less. So they won't eat equally. That's for sure, right? So similarly, if I've got address like this is the address, and I've got address like this, small address, big address. So for this guy, you will see Informatica might generate like 20 tokens. For this guy, Informatica might generate like 8 tokens. And you understood, right? So based on the length and complexity, Informatica will generate this multiple tokens. So this number is not fixed as such. It will vary depending upon the data. Okay. So depending upon the data, this will vary. Now the question is, so this, I just said that Informatica will generate 20 tokens. Fine. Can I play around this thing? Like, I don't like 20 tokens. I want Informatica to generate like 30, 40 tokens or like 10 tokens. I mean, I want Informatica to increase this thing. Can I do that? Yes, you can do it. So for example, if I go here to one of the configurations, okay, so see this key type. See, I've told you that it will be based on address, right? So it's not necessary that it should always be based on address. You can use address, you can use name, you can use organization name. So you can use 3 things. So you can use name, organization name, or the address. Clear? Tokenization can be done on any of these 3. Just these 3, not more than that. Other things like phone number, you can't do it on phone number. Okay, so that's a rule. Now if you want to play around the tokenization, then you have got 4 buttons: standard, extended, limited, preferred. So if you go with like the default is standard, so standard would be like approximately if it's generating 20 tokens for this guy, and if you make it extended means more, so this will result in probably 25 tokens. And if you want to make it less, then you use this option limited and preferred. I'll tell you, for a normal guy, extended means 10 tokens, standard means 7 tokens, limited means 3 tokens, preferred means single token, 1 token, that's it, just 1 token. We will see this when I will run the job, tokenization job. I will show you how this options, all the 4 options, how they work. But as of now, just understand that this just uh, influences the tokenization process. Okay, and I've told you that this is, in our example, this is address. It can be address or person name or organization name. Whatsoever it is, this key is called as a fuzzy match key. Clear? The key based on which you will perform the tokenization is called as a fuzzy match key. So what is my fuzzy match key here? Address. In this example, what is the fuzzy match key? The organization name. That is the fuzzy match key, because it is configuring this thing for the organization. So that's the fuzzy match key. Okay, you have any doubts?
Sunil, can I do matching on like more than 2 columns or 3 columns, or just only we can do the matching on 1 column only?
You can see here that the strategy is organization, but you can see it's based on 2 columns here. Okay, so if you want to add more columns, just add more columns. Okay, so columns you can always add it, not a problem. So what it will do is it will concatenate 1, 2, 3, 4, 5, and then your logic will be based on these 5 columns.
Okay.
Okay, we will see this configuration, but basically this is the concept of tokenization. The process of tokenization is basically to create the match pair. So if I go back now, I've got something called as pre-match, then the actual match. So now the tokenization is done. Let's assume that the tokenization is done. So what is the result of tokenization? The result of tokenization is you have match pairs. That's the result of tokenization. Can you tell me that 101 and 102, is it a match or is it like no match? Can you tell me? No, you can't tell me, because see, there are two things. Let's say you want to conduct a cricket World Cup, then you have India versus South Africa, let's say. So this is just a match pair, right? Can you tell me which one is winner? That is the second step. The actual step is the matching, which is a different step. So first step will just create the match pair, that's it. It will just create the match pair, nothing more than that. Okay. The second step, that will do the actual matching. Real matching will happen in the second step. Okay. So we will see the actual matching now. Actual matching is very simple. It's based on 4-5 columns. Like for example here, let's say if I check a rule randomly, so let's say this one, then let's say this rule. Okay, so this is simple rule which says that okay, addresses, then the generation, the party type, the postal area, the name of the person. So how many columns? 6 columns. So if 6 columns match for 2 records, if 6 columns match for 2 record, then those 2 records will be considered as matched. positive match. Okay, that's what this rule specifies. So you can understand that matching, actual matching will be based on something called as a rule, that is called as a match rule. So this is match rule. Okay, that's um, this is how it is based. And for your information, these tokens, I talked about these tokens, right? So it looks like something different. Now see these tokens, where this will be stored. These tokens will be stored in the strp table.
Sunil, does this token like are case sensitive?
No, token is not case sensitive. Token is not case sensitive, and this is how it looks like, the token. Let's say if I say ORS sample. Okay, the listener I have not configured here. I have to configure the listener. One second, let me check if toad is there. Okay, anyway, just remember, as of now, we will see this later, that the tokens are something, it will be generated in a table called as strp. Okay, this is one of the system supporting tables called as _strp. This is where the tokens will be stored, and this is like, it's a permanent table. Okay, don't think that this is like truncate load table. So in our case, for 10 million records, tokens will already be there in here. So tokens will only be regenerated for 3 records. Only for the 3 records tokens will be regenerated. Okay, remaining 10 million records, it was already done. So once it is done, it will just be stored. Okay, it won't be regenerated. Clear, right? So this will be a very big table in your system, and probably this will be your biggest table in your company, and this would be approximately like 6-7 million records will normally be there in this table at any point of time. Okay, we will see that. You have any doubts, you can ask, because tokenization, that's the complete process of tokenization. Tomorrow we'll start with the matching configuration, the match rules, the match columns, the match rule sets. That is nothing but these are the match rule set, match rule, match columns. Then we'll try to configure it. Okay, and what you do is, the new configurations I have already uploaded in the Google Drive, so you don't need to do any change in Hamachi. So Hamachi here, this is Hamachi, don't do any change here. Okay, no change is needed. Just download the new file and use the new Cyprian file and TNS names files. That's it. Okay, that's the only change that you need.
Sunil, so as far as tokenization is concerned, all we do is just to choose the fuzzy key, i.e. either organization, name, or address. That's all we do.
That's correct. That's what we do.
So the length of the keys, all that's up to Informatica.
Yeah, that will be handled by Informatica.
Okay. Thank you.
Okay, so tokenization, whatever we have studied, everything will happen internally. Okay, so we studied the internal things, so it's not necessary for you, but just to understand tokenization, I given a view how it works. But you just need to know the tokens are generated. If they are same, match pair is formed. That's it.
Okay. The tokens that are generated, do we see them anywhere? Is there any?
We can see them in strp table. I'll show you tomorrow. The tokens,
Okay.
I'll show you tomorrow. Today Toad is not configured. Tomorrow I'll show you.
Okay.
Sunil, for this Hamachi, we need to again have a new network password, or
No, Hamachi
will
don't
it be
do
the
any
same?
change. I told you, right? So don't do any change in Hamachi.
Yeah. Actually, I reconfigured my system, and I have one request has been sent to you for accessing Hamachi. So
You try to access it
only
from
after,
a single machine. Don't change the machine multiple times because it creates confusion.
actually, it's a Lenovo PC. I am not using the earlier one. You can just revoke that one.
Okay, okay.
This is Lenovo PC.
Okay, I'll check it.
So only after connecting to Hamachi, only then I can connect to Toad and other items, right?
Yeah, yeah, right.
Shall I send a screenshot of this login Hamachi, my PC name, or
Yeah, you send me. I'll check it.
okay, okay, thank you.
Please share the link. This is Abhishek for the new configuration.
There, you just refresh the Google Drive. It will be there in the same Google Drive link.
Okay.
Okay. Okay, thanks guys.
Sunil.